Thank you for joining XROM, India's first AR/VR focused podcast. And today I'm delighted to have with me Mr. Michael Rubloff, who's the founder, managing editor of Radiance Field. He's a leader in the field of Radiance Field, a cutting edge technology that enables photorealistic 3D rendering of scenes and objects. With over 2 years of experience in creating and managing digital content, products, and communities around Radiance Field. He is the founder and manager of the largest Discord community of Radiance Field, where he fosters a supportive and collaborative environment for Nerfs, enthusiasts, and creators. So, Michael, really appreciate you taking time and being part of the podcast. I think we're sitting at a fantastic point of time. The tech is converging, this AR, VR, MR, XR, metaverse, spatial computing, and then there's this underlying technology of Web 3.0, which I believe is going to be playing the economic role of these metaverse platforms. And there's this AI which is coming in, and these LLMs and possibly maybe NPCs are already like intelligent. So exciting space. And I feel that with the cusp of us possibly moving from a 2D interface into the 3D interface. You're the leader in the face in this field. So maybe give your thoughts on this transition. What do you think is going to enable this transition of us going from a 2D interface, flat interface, right from your TV, your phones, and your computer screens and the theaters to the 3D world?
Yeah, no, exactly. I think it's already begun in a lot of ways. It's been pretty amazing to actually witness it happening live. It feels like every single day, without exaggeration, there's the possibility of another paper coming out that's just completely transformative and allows us to really just move forward significantly faster. And I think we've seen quite a few examples of this over the last 2 years, really from the creation of Neural Radiance Fields to most recently, or I guess now there's a new radiance field method, but there's 3D Gaussian splatting as well for real-time radiance field rendering. And you have all these methods that are really starting to allow us where we're starting to get actual lifelike interpretations of what the world looks like from baseline 2D images. It's not like we're introducing something that has a proprietary like paywall in terms of access to a camera or some, like a LiDAR system. This is a technology that any camera is capable of producing. It could be, the latest iPhone. It could be a, film camera from the 1990s. It could be a cell phone from the early 2000s. You're able to create completely photorealistic and lifelike interpretations of your world around you just from these methods. And, given that, I think that we've seen a lot of larger companies start to indicate as well that this is something that they're looking at incorporating into their actual, product stack. And this includes, companies like Google and Apple. Actually, somewhat recently listed a job opening for a radiance field engineer, where it says right in the JD that their goal is to be re-implementing all of Apple Maps with this. And it's going to be, I think, completely, omnipresent in our everyday life, which is really exciting to me because that's the same way that 2D is right now. I think it can be a bit inconceivable to imagine a world that's completely lifelike in every single way and to have it be in full 3 dimensions. But at the same time, that is how we, experience our lives in a daily, capacity. And so I think it's only natural that we would be able to move our lives from, flat 2D image into an actual 3D lifelike representation.
Completely W on that, Michael. Yes, I think for the longest time, we've been stuck to these 2D interface, right from your TV to your screens, your theaters, to your computers, to your mobile phones, and but it's done us so good. I mean, through these 2D interfaces, the mediums such as photography, or even cap movies, it's like trapped memories, but these are all in 2 dimension. I, it's fantastic to think what it would look like when we'll be able to, create these memories of 3 dimensions. I mean, how fantastic would that be? Go back to any like image which is 3 dimension, and then you go back and you look, oh wow, that's something which you notice for the first time. So like I'm really really exciting for that world, and I'm sure we are being nudged into that direction with the companies such as Google and Apple and Meta and Magic Leap and so on and so forth. So I'm really looking forward for that. Before we get into the technology stack that you mentioned about Nerfs and 3D Gaussian splatting, I mean there are obviously the other tech stack which has been traditionally we've been leveraging for 2D to 3D render. One is photogrammetry and the other is volumetric video, where though that volumetric is still not being mainstream, there are people who are working on it. Would you be able to explain the concept of photogrammetry and volumetric creation in the process?
The way I interpret it is it's really being able to get either depth information from photos and being able to use it for more of those purposes. And so one of the differences between photogrammetry and say, radiance fields is really comes down to the view dependence. That's a feature that radiance fields are kind of known for. And what view dependency means is that depending on how you move through a scene, the actual colors and reflections and shadows follow it, and it's realistic. It's actually, true to life, whereas photogrammetry is more utilized for surveying, and doesn't really come with that same lifelike interpretation. And photogrammetry has been in existence for quite a long time relative to radiance fields, and has been really well demonstrated its value. But I think that over time, and it's, I think, to a large degree already begun. I think radiance fields are kind of going to enhance everything that photogrammetry has built, and it's they're not the same thing, but I see them having a lot an overlap together. Whereas with volumetric, it seems like the idea is also similar in terms of taking, three-dimensional, or sorry, 360 video of, say, either a person or a scene, and being able to create something that you can kind of weave around it and move around during it. But at the same time as well, I think that also suffers from that lack of view-dependent features as well. And so there's a certain threshold where it can get up to, from what I've seen. And I'm not an engineer by any means, so I could not be describing this exactly correctly, but from what I've seen of volumetric video, it doesn't have that view dependent that kind of brings that actual lifelike quality to its captures.
Right, right. Yeah, yeah. So I think, you rightfully pointed out, I mean, photogrammetry is a static way to capture 3D, and you take your camera and, walk around the object, and
Yes.
you shoot possibly 100, 200 images of the asset, and then you put an engine there, color, you have like a 3D static image. And volumetric is when you have these like multi cameras, sometimes, like this Intel studio had used somewhere around 300, 600 cameras, and you
Right.
capture asset from all directions, and then eventually it has you can walk through in that in that environment. So really cool. Now you mentioned that Nerf is pretty much similar to for photogrammetry. Would you be able to describe Nerf? How does it work? With photogrammetry, you have to go somewhere around 100, 200, 300 images, but in Nerf,
Right.
it's basically you can do a couple of images, and the computer does the entire processing. Could you elaborate on that, please?
Yeah, sure. So essentially, they all start out with a pretty similar input process. They're all take 2D, normal 2D images. You would either, walk around, or you'd have a drone, you fly around. So once you've actually captured that, you're going to run it through a method called structure from motion. And essentially what that means is it's really aligning all of the images that you feed it into understanding, like, where should each what should the resulting field actually look like to be as lifelike as possible. And the main method for structure from motion is called ColdMap. That's the one that is used most often from radiance fields. But I think that through the end of this year, we might see a potential replacement to ColdMap. It seems like there's not a lot of love for ColdMap in the researcher community, and so I think that might become significantly stronger and more tuned for Nerfs. But anyways, Nerfs, like their name implies, utilize a neural network. And so what they're fed through is something called a multi-layer perceptron, or an MLP. And that's actually what's going to train the Nerf. And that's what introduces a bit more of the time that it takes to train a Nerf, say, compared to 3D Gaussian splatting, which does not actually use a neural network. Though A most recent radiance field method actually reintroduces a neural network, but a much smaller one. And they found that you get significantly higher fidelity results than 3D Gaussian splatting even. And so I think that it kind of signals something in the future as what the two technologies might represent to one another. But essentially, Nerfs have that neural network and well, they're trained. And that's pretty much the how they're put together.
Right, right. So, Michael, tell me. I mean, you described nerves, and how does this work? For example, how many pictures would somebody need to take of an asset to, like, I mean, a bounded scene, like there's an
Yeah.
asset. So, if he needs to kind of take pictures, how many see appear images that he or she might need to take? And what's the process? What are the engines that you need to take this into to create a nerve? We'll be glad if you can explain the process.
Yeah, yeah. So for me, it's a really great question. It's one that I think um, doesn't have a ton of documentation on it. And for me, what I've found is the least amount of photos I've ever used for like a somewhat successful Nerf has been around 20. And that can mean even just 20 frames sliced out from a video. But I typically find myself using somewhere between like 80 and 130 images. It seems to be the sweet spot for me to get just complete coverage around a scene. But I have seen people go all the way up to, several hundreds, going from like 500 to 1,000 images. I've found that to be a little bit of overkill, but if it results in a clean capture, but then it's completely fine. And one benefit of using that many images is that you also have the ability then to pull out the very sharpest images to use, because essentially for all radiance fields, they will map exactly what they see in from given to them. And so when you introduce blurriness or something like that, or you have motion blur, it will result in either artifacts, or it won't know what is there, and so you'll be confusing the method, because that blur will appear in that photo, but it won't appear in the ones before or after, and it will not understand what that object is, and so it will make its best approximation. So it's really, really important, probably more so than anything outside of generating parallax, is to introduce uh, sharp images to the actual data set that you're using. And so when you have a higher data set like that, it's nice because you can cull it down into, so even if I have like say 150 images, I will go through just in like Finder or something. And if there's a blurry image, you just throw it out. It's just not, it's actually more detrimental than positive for you. And so when you talk about then like the places that you would go to it to actually begin processing, you have quite a few different options. There are a few cloud providers such as Luma AI or Polycam, or now there's also a cloud instance of Nerf Studio where it's really simple. You can just drag and drop, your images or a video file, and it will just do all the work for you. And about 15 minutes later, it's done, and you can look at it on the internet. But that said, there's also quite a few methods where they are just trained locally on your computer. And so the companies like Nerf Studio, again, the formal instance of Nerf Studio, NVIDIA has Instant NGP, and hopefully adaptive shells will be released publicly soon. And there's other companies like PostShot as well, where you're able to just essentially start that process. And the process really is going through structure from motion. And so what you really need to do first is just, it's pretty much like one line of code that you can pull. I actually have a guide on my website because it took me forever to figure out how to do it at first. And now it's actually very, very simple. And once you do that, you get a transforms.json file a lot of times. And from there, you're able just to load that and begin the formal training process. So the training process is completely separate from the structure from motion process of it. But some of the platforms like, the cloud-based ones, they do it all for you. And so there's no need to really, have that separate step.
Right. So you mentioned that you normally your process is either 20 frames or sometimes you go up to somewhere around 80 or 100. You
Mhm.
think that the way there's more and more new papers coming up with 3D Gaussian splatting and nerves, do you think that we could come to a point where it could be just possibly maybe one image and maybe the neural network, the perceptron behind it could be able to kind of, create that data for you? Is that something that you think could happen? And maybe also talk through the process of, because you are also a content creator, you've been creating these nerfs. What's been some of the most challenging uh, um, shoots, captures that you've done with nerfs?
I found like almost every single day that I've been just wrong about how fast I thought the technology was going to go, or something that I thought would just take a very long time to create is just suddenly either done or has been done like a while back. And so I think it is going to be pretty likely that we will see it get down to potentially a single image. If you take a look, there's actually a paper towards the end of the year from Google called Recon Fusion, where essentially they utilize stable diffusion, and they're able to generate shockingly clear results off of three images alone. And they have a on their project page, there's a slider as well that will allow you to kind of see like what happens if I have three images, what about six or nine or whatever. And the fidelity is pretty shockingly good for, that. And I think that it only represents a future where uh, these methods just get stronger than we can, imagine. And I think it goes back to just, we have no idea what the ceiling is of this technology. It's like I see papers like VR Nerf from Meta where they're shooting IMAX quality Nerfs, and the bottleneck is the compute. And at that point, I think it's really more of an engineering problem in terms of how do we get that to be more manageable onto like an everyday consumer device. But in terms of the actual fidelity that comes out of it, we have no idea what's possible. And on the content creator side, that's where I get super excited about, because without that limit, without that restriction of knowing as long as I have access to X system, even if I shoot something now, in the future, it's going to be easier for me to just reprocess. And this is what I've actually done repeatedly with some of my early captures, because when we first got started, I can give my background on some of the content creation side, because that's actually how I got roped into all of this, where it was, I think, like the very beginning of 2022. And so I actually was trying to figure out how do I bring photography into three dimensions through LiDAR. And because I was really interested by the fact that everything was super precise, everything would be one to one, but like, photogrammetry, it doesn't have that view dependent feature to it. And so I saw one day on Twitter, someone post something from Instant NGP or Instant Nerf, and very quickly it was like, I'm no longer doing LiDAR. I'm going to teach myself how to do this. And there were a lot of trial and error that came along with that. And so some of the initial things was I took way too many images, and I took way too many high resolution images because I wanted to see how lifelike could I get it immediately. And so the problem I ran into repeatedly at first was just, running out of memory, where my graphics card just couldn't handle what I was feeding it. But since then, the actual requirements for VRAM have fallen significantly, and I've been able to actually retroactively go back to those original captures and reprocess them. And now they actually work out. And so it's the same thing where the content you create now is only going to get stronger in the future, and without necessarily needing to adjust anything from your inputs, which is tremendously exciting to me, because it only represents a future where we have stronger outputs from our captures. And in terms of like some of the trial and error that I can talk to, for me, I was most excited about human captures. I think that the way that we document our lives is like critically important, and it's why I wanted to bring photography into three dimensions. And big challenge is getting people to not move while you capture, because like I said, with if you introduce any motion blur or just not consistency between frames, it will not understand what is there. And so one of the original quests that I went down was, how do I get my capture time down as fast as possible? And so it used to be, I used to have to hold still for something like 15 minutes, where it was really difficult to do that. But I knew that if there was a way to get faster at this, then it could be really great. And so as I got better with actual motions of walking around a subject or going through there, I've been able to get it now down to somewhere between like 20 to 40 seconds or so to capture a person. And it's still definitely the hardest one compared to anything else, except for maybe like a tree blowing in the wind. Um, but it's been a steep learning curve to figure out what works, what doesn't work. But once you figure it out, it's actually tremendously easy to execute on. And I think that, similar to photography, where you had in like say in like the days of like daguerreotypes, if you look at the way that people are posed, it's very similar to a lot of the captures you see uploaded to Twitter, where people are like, trying to really hard. You can tell they're trying to not move, or they're sitting in poses where they're trying to not move. And I think that there's a lot of similarities to that. So from the content creation side, I think that we will see uh, we will see a lot of similarities to the rise of photography, to the rise of radiance fields.
Right, right. Yeah, yeah. So I think exciting things are going to happen. You're going to transition from 2D to 3D. I've seen some fantastic pieces of these nerfs, these captured through drones and things like that. Would you be able to share, like, maybe tips or tricks of the trades, something that you can, maybe see these
Yeah,
content creators can, I mean, lean on to, building their own nerfs, and also maybe, talk about, like, once you capture these, how do you bring it into in engine? What's the best engine to bring it into to, maybe edit these out?
yeah. So here I'll answer the first one. So a really great tip that not a lot of people know is that ISO does not matter for your images. You can shoot pretty much like the highest I've gone up to my camera has been about 30,000 ISO, and I still get relatively clean results out of it. It's not perfect by any means, but it physically pains me to set my camera that high for to shoot at that level, but ISO does not matter. And so a lot of the average ISO on my shoots are between 10 and 15,000, which I would never ever shoot at normally, but it just falls away. So I would say if you're taking a drone out, or you're going to go shoot, crank your ISO up to that level, to be able to get a higher shutter speed. The shutter speed really is the most important part of the exposure triangle when it comes to radiance fields. It's very different from standard photography where, you really don't want to push your ISO too high. But I would say that the pecking order, it's not necessarily like an equilateral triangle for radiance fields. And to answer the second part of your question, there are quite a few different platforms that exist now. 3D Gaussian splatting has made it a little bit more modular in terms of where you can edit them. So for instance, with like Nerfs, if you had like a .luma file, which is the Luma extension for Nerfs, it's not something that you could bring into say like just another editor across the internet. It was proprietary. Whereas the resulting PLY file from a Gaussian splat is able to be translated and edited in other platforms. So you could create something in Luma, bring it into play canvases, super splat, edit it there. And then from there, depending on what your individual use case is, you can decide what platform is best. So there are now plugins for Unreal Engine. There's plugins for Unity. I think I've seen them in Blender as well. But you know, you can also now utilize them in WebGL and through Spline as well if you want to, include them natively on your website, which is something that I'm actively investigating because it's, I think it's just representing a shift forward into the transition to 3D. But it really, a lot of these platforms you can bring them into, and most recently, actually, you can now bring Gaussian splatting into Houdini as well, which is really cool. And you can start generating, synthetic data sets. You can modify them there, which is just like another industry tool that I'm really excited to see, begin getting adopted. So it depends on what your use case is, but that said, there's not nearly as much of a bottleneck to beginning to create with them or bring them into like Unity or Unreal Engine as it was like 2 years ago.
Right. So with nerfs, you mentioned that you end up using 20 frames, sometimes 80 or 100. With 3D Gaussian splatting, how does that work?
So it's the same. So it's the same initial data sets because the first part of it up through structure from motion is exactly the same. And so I use the exact same data sets for Gaussian splatting as I do Nerfs. And so that's the really great thing about it is that, they're both radiance fields, and thus the inputs are exactly the same. And I don't really do anything different for either method. And, I just kind of compare them to one another, and they just both work.
Right. Have you seen peers, I mean, who are doing interesting work with NeRFs or 3D Gaussian splatting that you would want to share with our listeners?
Oh yeah, there's so many. There's so many like really incredible creators. The first one that came to my mind is his name is Great Eterna, who essentially back in like early 2022 or so, there were very few people who were posting on the internet back then about like Nerfs. And I remember the day I figured out how to use FFmpeg, which was a very like minor accomplishment. And that day I messaged him and I was like, oh, I figured out how to use Nerfs or videos for Nerfs. And he's like, oh, cool. I just figured out how to do 360 videos to slice them up and then like, be able to get really realistic, unbounded scenes. And I was like, oh, okay, that's much cooler than what I have. Um, so I would say, Grade has made some really, really cool visualizations across London, was where he's based out of. Some other people that come to mind are Jake Olson has created a Nerf short story, which actually was a runner-up in Runway ML's film festival last year. And he's done Nerfs for Zayn Malik from One Direction. He's done R.L. Grimes, some of his music videos as well, which it's just amazing. When I was talking to him when he was first doing it, for just the one R.L. Grime music video, I think it was some like 700 plus individual Nerfs that were created for that one music video, which is just insane to me. And Jake also does a lot of work exploring relationships between humans, which I think is just like fascinating to see in 3D. Some other people, I really like Simon Green's work, where he is a engineer who just figured out how to use, I think, shaders pretty early on with Nerfs. And when I first saw his work, I was just like completely mind blown by it. And I very much would like to learn how he does what he does. And yeah, there's quite a lot. I could probably like rant for a while about creators. And it's actually something that I think is really important to popularizing this technology. And so at SIGGRAPH this past year, we actually put together the first ever Nerf exhibition where myself and a few other people curated about 20 different creators or so, and we were able to rent a venue for a night, and we had about 20 different screens, each with like their own individual artwork on there, and we had about 1,100 people come, which was significantly more than we had projected, and it was really exciting to see. So I'm really hoping that throughout the course of this year, it gets more attention for the people who are creating with them. I guess myself included in that way.
Completely. You mentioned about static and dynamic nerves. What's the process with dynamic nerves, and what's the duration of a dynamic nerve, because with static, I mean, you need to take lots of pictures, you need to go around the assets. When you're talking about dynamic nerve, how does the process work, and what's the duration of a dynamic nerve that we can do at this point in time?
Yeah, that's a good question. I'm not sure if I'd be able to point exactly as to like how the back end works for them, but from the examples I've seen thus far, um, I haven't seen any that have been like tremendously long yet, but I don't it's going back to like the example of VR Nerf, I don't see there being a limit outside of the compute that's available to process them at this point. And so um I'm not sure if there is a limit for dynamic Nerfs. I imagine that there isn't one, because as long as you have the compute necessary, uh, I think it will just continue to it will continue to scale.
In the course of the conversation, you were mentioning about the need for popularizing this technology, and you've been doing a bit through Radiance Field, and Radiance Field is like really, really growing. It's got its own marketplace. It's got the largest Discord group. Would you like to talk about a journey?
Yeah, it's been a crazy journey so far. Where we talked a little bit about the creator Great Eterna, and in the second half of 2022, I was, chatting with him, and I kept DMing reporters across different publications because we would see he would show me some of the work he's done and I'd be like, this is amazing. Or then I'd look at like the research and I'd be like, I don't think people are aware of what is actually being published right now and like what it represents. And so what I would do is I would just start messaging people at different publications and literally zero people ever responded to me at any point. And as part of one of those conversations with him, I kind of just said, if people aren't going to cover it because there's just no precedent for this, I'm just going to start to publish it. This way, there will be at least someone covering this, and then hopefully in the future there will be a sort of like a fear of missing out for some of these publications, and they'll feel like, oh, here's this guy, writing about it. Maybe we should cover it as well. And I've actually seen that happen. It's pretty crazy. It's actually come a bit full circle because one of the reporters I messaged just wrote an article about 3D Gaussian splatting a couple weeks ago and featured Great Eterna in them, which was just like it was pretty full circle for me. So I was very happy to see that. And I just felt like, this technology is so transformative in what it allows. I felt like it was only appropriate that there was some kind of formalized catalog of how it all progressed forwards. And, I wanted to be able to document that from a more, I guess, publication side. And it also had the benefit of allowing me to really start to understand, at least in more depth, how these methods are working and what is and isn't possible, which has been really great. And on the side of the Discord, when we first got started, so this was like all the way back in like April of 2022 or something, there were very, very few people posting on Twitter that we could find that were talking about Nerfs. And, for me, or for my friend Sean and I, we didn't have any background in doing this. And so we really were looking for help from people. And the one person we were able to find, there's this guy, Jonathan Stevens, who since have become pretty good friends with. But at the time, we were like, we have to get this guy's attention. We don't know what to do because we can't figure this out. And so as part of that, we were like, well, maybe if we're having this problem, maybe other people would be having this issue as well. And, there was just no documentation on the internet whatsoever. And so we started a Discord with the somewhat selfish hope that people who would actually understand the technology would join and we can ask them for questions. And, what's it's grown into now is hopefully a platform agnostic way that you can join the community and ask for questions, have access to the teams itself who are creating in the space, and be able to actually serve as a helpful repository for people, because that's ultimately what we were looking for when we were getting started. That's its own story, but yeah, so it's been able to grow into a sizable community. And there's a lot of more work and optimization that I would like to do on the Discord, but I just have not had it hasn't unfortunately been a priority with everything else that's been going on.
No, but superb. How cool is that, Mike? Because I think of what little I know, I think yours is one of the first of its kind Nerfs focused website, that I know about. I don't really know if there's another one over there. And you have also created a Discord group, and I think it's so very needed for this, technology like this. Because I really do believe, honestly, I mean, that we are going to transition from a 2D to a 3D world. And I think Nerfs, 3D Gaussian splats, spatial computing, metaverse, I think it's going to play such a huge role over there. You also have a marketplace of sorts where you kind of like gather people who are creating these Nerfs to post. How does that work? And is there a way where like content creators can monetize this?
Yeah, it's a great question. So for me, when I was first looking at creating a marketplace, I kind of thought back again to the beginning of all of this, where we didn't know what we were doing at all, and which I think a lot of people didn't. But we spent quite a lot of time doing trial and error to figure out like what does and what doesn't work. And what it made me think back to was when I first learned how to take a image, how to actually uh, you know, do photography. And for me, when I first got my first camera, I didn't take it outside for like the first month of having it because I felt like very intimidated by going out and being like, all right, I don't know what settings to do. I don't want to look like an idiot walking around this street or anything like that. And for me, it was like a big issue where I was like, I'm not even using this thing that I own now, even though like I really want to. And so what I ended up doing back then was I'd go to like sites like Flickr at the time where it would list all the metadata and I'd look at, what the settings that people were using. I'm like, oh, they shot at like, this aperture or this shutter speed or whatever. And this is how they got like this, like the bokeh and this. And that helped me like feel comfortable to go out and actually shoot. And so when I was developing the marketplace, I thought, if I'm able to create a library for people to go in and hopefully do something similar where they can feel like, oh, okay, I can go out now and feel comfortable shooting this, or here's something that like here's it right in front of me. Here's something that I can download and I can pull up on my computer screen and be or going into VR with and actually see the output. And so that was the driving factor behind there. It was a lot of work to get it up and running, more so than I initially expected. And so I would like to be able to have a library because at this point now, my personal library of Radiance Fields is probably like a couple thousand or so. And I would like to just open the vast, vast majority of all of them for people to download and try out for themselves. But at the same time, yeah, there a lot of these methods you would be able to just monetize them themselves. The one issue you would have to run into and be careful of is just individual licensing in terms of, if you are going to use the original INRIA method for Gaussian splatting, I don't believe that you can sell that just as is. You would have to license it from them. But that said, if you take a look at like, Nerf Studio or Luma or actually I'm not sure Luma's policy on selling your files, but if you look at Nerf Studio or and I'm not sure Polycam has stated their stance on it, but if you take that resulting PLY file, you can 100% sell that, and I think it will be quite a lucrative, way for people to monetize what they've captured because a lot of the world just has not been captured in this way, and so that goes down the rabbit hole of production and virtual production is just like, well, once we have these assets, are we able to shoot infinitely with them? And yeah, the answer is yes.
Yeah, exciting things, because I think, most of these games now are using like a mix and match of, creating computer graphics versus, having these assets, which is, created, shot through, nerfs and stuff like that. So yes, I think exciting things. Any advice to aspiring creators, studios who want to explore nerfs and 3D Gaussian splats?
Yes. Yeah, I have a lot of lessons learned. Definitely, try and figure out your capture path, I think is pretty important. It depends what you're trying to capture. If you're trying to capture an object, the way you go about capturing it will be fundamentally different if you're just trying to capture like a location. Locations and objects are significantly easier than anything that moves or has the possibility of moving. So I would say starting with like an object is probably the easiest way to do it. Make sure you have enough room around the object itself. Like so don't set up something like right in the corner of a room because you're not going to be able to walk around it. You're going to have a limited, range of mobility to go around it. But another recommendation I would make is shoot as wide as you can, as you have access to. So if you're shooting on an iPhone, which is a really great capture device, actually, iPhones, you can get shockingly good quality out of just any camera that you have. But shoot at the widest, like the 0.5 setting there, because the more information that you can introduce to it in the fewer amount of images, the better. I would make sure that you do not drop your shutter speed below really 1/500th of a second. Some people would say, so I think you could probably push it to like 250th of a second, depending on your focal length. Your focal length really will make a big difference because if you're shooting handheld, for instance, on like say if you have a fisheye lens, the camera is significantly less susceptible to handshake at 8 millimeters than it is 70. And so it is way more forgiving in that way. But that said, I've experimented with a pretty wide variety of lenses, and it's always possible to get clean results out of it, but you'll have to be a lot more careful of actually capturing it during your uh, yeah, during the capture process. And from there, probably the easiest way to get started would probably be one of the cloud providers. If you're brand new to Radiance Fields, I think, just dragging and dropping into either Luma or Polycam, or if you're on Windows, using like PostShot or Xspada, they're a lot easier to just get started with because they're really intimidating at first. If you hear the words neural radiance fields or 3D Gaussian splatting for real-time radiance field rendering, it's really intimidating. And I'm trying to figure out how to make it more approachable so that, because it's not easy if you don't have the background for it. And if you're like, oh, well, just go check GitHub. A lot of people have like never heard of GitHub outside of this community. And, it's I think a large not challenge, but it's something that I try to think through about how can this be more approachable? Because in actuality, it's very easy to capture these. It's actually, not difficult. It's just sometimes you have to be willing just to go and start and try out something. You don't need to leave your home to do it either. You can go just downstairs to a kitchen, or if you have a backyard, go to your front yard, go to your street and just walk around it for a little bit and try it out for yourself because the best way is just to jump in with this. There's really no other way
Right,
that I
right.
found.
I guess yeah, that's the best way approach. I mean, get your hands dirty. So, Michael, really, really appreciate you taking time being part of the podcast. My last question to you. There are so many new papers, coming in. You mentioned about reconfusion, 3D reconstruction with diffusion priors, and there's NeRF, which is text-driven generative object insertion into these nerfs. How do you think that's going to pan out? What's the future? I mean, do you have an inkling, where this pace of which these papers are being coming in? What's NeRF 3D Gaussian splatting is going to look like in the next few years?
Yeah, it's only going to increase. I think the volume of papers that come out are just only going to increase. And it's the really exciting thing is that legitimately it could be any day that that paper is released where it just fundamentally sets things forwards. There was a paper somewhat recently that came out called TRIPS, which is trilinear point splatting for real-time radiance field rendering, which I've kind of alluded to throughout this talk, where it combines 3D Gaussian splatting with another method that uses a neural network. And so and you get higher fidelity outputs from that. And so given that, I think the future of radiance fields, I don't fully understand the competition that's been like created on the internet about like, oh, 3D Gaussian splatting versus Nerfs. I think that's a little short-sighted to be honest, where we have zero idea of the ceiling on either technology. And so I think that they're both exponentially going to get better, and they're both going to work in some ways, I imagine, together. And I think that we're going to see hybrid iterations of the two that, combine to create just truly like fantastical outputs. And I think for the future, we're going to see a march towards near instant nerfs. And when I say that, I literally mean like instant, where it will just be, one of the nice things about Nerfs right now is if you hit enter on, like, say, Instant NGP, you can actually watch the entire world be created in front of you. But I think that in the somewhat near future, within the next couple of years, it truly will, you will just upload it and it will be done. Just like how you take an image on your smartphone or whatever, and it's just already in your camera roll. I think that represents a potential future as well.
Right. How cool is that? I really look forward for that future because I mean, there is so much friction. I mean, currently, when it comes to nerfs and 3D Gaussian splats, hopefully, I mean, maybe we'll come into a world where it's possibly one image, one video, and voila, the neural network perceptron behind does all the magic, and you've got like your entire 3D scene or asset created. So thank you, Michael. Really, really appreciate you taking time being part of the podcast. Wish you the very best for Radiance Fields, your .com, your website. And to my listeners, if you like what you see in here, then please press the subscribe button. Until next time, see you guys. Bye-bye. Thank you. Thank you, Michael. Really appreciate this.